In this video, I'm going to work through the two Avogadro's law practice problems from your PowerPoint slides. Okay, the first one comes up on slide number 16, and that question reads, if 2.11 grams of neon gas occupies a volume of 12.0 liters at 28 degrees Celsius, what volume will 6.58 grams of neon occupy under the same temperature and pressure conditions? Okay, so in this question, we are using Avogadro's law, which states that the volume initially over the N here, remember N is moles of gas. That relationship is the same under initial and final conditions, which means as one increases, the other must also increase. Okay, again, volume and amount of gas are directly proportional. Think about that, y'all. That would make sense. They're directly proportional. Okay, so in this problem, it tells us initially, if you had 2.11 grams of neon gas. Okay, of course, we know N is not grams, it is moles of gas, so do a quick molar mass conversion using the molar mass of neon gas, which is 20.18 grams of neon in every 1 mole of neon gas. Okay, so initially we have 0.105 moles of neon gas at an initial volume of 12 liters. And they're saying, what if, instead of 2.11 grams, what if you had 6.58 grams of neon? Okay, again, we need to know how many moles that is. 1 mole of neon contains 20.18 grams of neon. Okay, so there we have 0.326 moles of neon gas. Okay, and we want to know how much space would that much gas take up, or what would the new volume be? Okay, so just as we've done before with Charles's law and Gay-Lussac's law, plug in your variables. Okay, so our initial volume, we've got 12 liters over 0.105 moles. Set that equivalent to your final volume over 0.326 moles. Okay, just as we've been doing for these types of problems, cross multiply and divide. So our new volume will be equivalent to 12.0 liters times 0.326 moles divided by 0.105 moles. Okay, you see moles cancel out. We're left with liters. Okay, when you plug this into your equation, you get 37.3 liters of gas. Okay, and think about this. This makes sense, right? You a little more than tripled the amount of gas you had. You a little bit more than tripled the amount of space it occupies, or the volume that it takes up. Okay, so that one makes some good sense. Then you move on to slide number 17, and we have another one. And this one's a little odd in the way it's phrased, but I think we can figure this out, okay, because I know y'all are smart enough to get this. Okay, so again, this is Avogadro's law relating volume of a gas and moles of gas present. Okay, and this question reads, a 13.1 liter sample. Okay, so right away, right, we know our initial volume is 13.1 liters of 0.502 moles of oxygen gas. So the initial amount of gas we have is 0.502 moles, and it's O2. Is held under conditions of 1 atmosphere and 25 degrees Celsius. If all of this oxygen is converted to ozone, okay, this is a chemical reaction. We have oxygen converting to ozone, O2 converting to O3. What will the volume of the ozone be? Okay, so we know that we are trying to find, I didn't put it in the question, okay, but I think we're going to assume here that pressure and temperature are remaining constant because this is under Avogadro's law. Okay, so we're going to assume those two are constant. But now we're saying we had 0.502 moles of oxygen. How much ozone are we going to have? Okay, so we need to do some thinking here to figure out our second amount of gas, okay? Not a big deal, right? We know that we can find a relationship if you do quick balancing. 3 moles of oxygen gas will give you 2 moles of ozone. Okay, well, we know that it's all getting converted. All 0.502 moles of oxygen gas is getting converted to ozone. We know that there are 3, flipped my conversion. We know that there are 2 moles of ozone produced for every 3 moles of oxygen gas reacted. Okay, we're saying all of that oxygen is converted to ozone, right? So we have 0.335 moles of ozone. Okay, so it's saying under the same temperature and pressure that this much oxygen would take up this much space. Under those same temperature and pressure conditions, if you had this much ozone, how much space would it occupy? Okay, so the hardest part there was figuring out what the heck your final number of moles were, okay? And for that, you needed the balanced equation and the mole ratio between oxygen and ozone. Okay, at this point now, it's just a plug and chug your values into the equation, right? So we have V1 over N1 equals V2 over N2. Cross multiply and divide. Your final volume would be equivalent to 13.1 liters times 0.335 moles divided by 0.502 moles, When you crunch those numbers in your calculator, you get 8.74 liters. Okay, and this answer makes sense, right? We had a decrease in the moles of gas present, right? Because 3 moles of oxygen, you're going to make fewer moles of ozone. Okay, the amount of gas in terms of moles decreased. Okay, the volume should also decrease. All right, so those are the 4 individual gas laws. We had Boyle's, Charles, Gay-Lussac, and Avogadro. Okay, coming up next, we're going to see kind of how, in all of those equations, you had one thing remaining constant. Well, what if there's more than one variable changing here? Okay, and for that, we're going to take a look at the combined gas law. That is coming up next. Stay tuned.